Good morning, everyone. Welcome to Autodesk Virtual Academy, brought to you by your friends here at KETIV Technologies. I'm Nigel Umbayek, your host for today and one of the customer success managers here at KETIV. Today, I'm joined by my colleague here, Jeff Perez. Jeff, how's it going?
Good, Nigel. How are you doing?
Good, good. So Jeff is on the customer success team with me. His formal title is Application Engineer, which means he's an engineer who knows applications, one of which happens to be Plant 3D, which we'll be going over today, and specifically the pipe specification creation within Plant. But before we get started, Jeff, can you explain what Plant 3D is to AutoCAD and what people use it for?
So Plant 3D is another AutoCAD-based software, and you could get this as a part of the AutoCAD specialized toolset. And there's electrical, there's various other tool sets a part of that. But specifically with Plant 3D, you're going to be able to leverage plant design or plant piping design within AutoCAD itself. Now, within the piping specification itself, we're going to look into this module to actually implement custom pipe specs that you may need for your own database or your own company.
Cool. And yeah, I know that Jeff's done some Plant 3D stuff before. This is just kind of an extension to that. So if you want to know more about Plant 3D, there's already a number of videos. I think Jeff has been on a lot of those and done some, training classes for those who have streamlined. So if you're interested in learning more about Plant 3D, after this webinar, let us know. We can get you some of those links as well. If you have any questions anytime, type them in. We'll go ahead and address those when we get to the Q&A at the end. But without further ado, Jeff, go ahead and take it over.
Perfect. Yeah, so we're going to dive into this PowerPoint first really quick. And as Nigel did talk about, let me make sure we're on here. So for today's agenda, what we are planning on talking about is Spec Editor, what Spec Editor is, create and modify specifications, branch table editor, build custom catalog information, and then actually implement the spec into your project. Now, for many people who don't know what Spec Editor is a tool set within AutoCAD Plant 3D that allows you to create and modify piping specification using industry standard part catalog. So out of the box, when you do the actual install for Plant, you're going to get two different additional modules that get installed with it. Spec Editor, and then there is Report Creator. Specifically with Spec Editor, Plant gives you basically a full database of different catalogs that you can utilize. And we'll go through those today, and I'll kind of show you where those rely on. And then we're going to talk about the branch table editor, how you could actually utilize the branch table editor to manipulate, add specific branches that you need for your pipe routes, or maybe you need to follow a customer specification that has their own unique branch table that you need to follow. So we'll go through defining what a branch legend is, assigning branch fittings, and then setting the component priority within the branch table editor. After that, then we'll talk about building a custom catalog. A lot of the catalogs that do come with Plant are very vague, the information that you have on there. So if you need to customize how some long descriptions are, or even some materials, anything within the catalog, maybe you need to actually tailor it to match some standardization that you have in-house. Maybe you want to bring this into an ERP system so that it can get translated into it properly. You will want to kind of edit these long descriptions and give it a little bit more information. It's kind of similar to how Inventor Content Center works, but specifically, this is going to be all within a catalog itself. And then lastly, we'll talk about reusing some of these specifications. You could use these custom specs as a template. So maybe you've built one spec already, and then you could utilize that as a template and begin to modify it, add on to it, or completely use it as a base point to make a brand new spec out of. Then we'll actually implement that spec into your project. I'll show you how you could do that. And then what I would like to also touch note is the configuring a shared content folder. And this is kind of guaranteeing and making sure that you're establishing a collaborative environment within your company. You really don't want multiple users working off of local data sets. You kind of want to have this at a shared network location. So if you know you're going to have more than one kind of pipe spec admin that's going to be building and configuring these specifications, I would recommend creating this shared content folder, and I'll show you guys how to set that up as well. All right. So what we'll do right now is we'll jump right into Plant 3D Spec Editor. So let me jump into that. And there we go. So I'm working with Plant 3D Spec Editor 2020. Now, what you kind of see within Spec Editor is this upper area within the Spec Editor portion. It's just 3 tabs that you're really going to be utilizing the most in here. It's the Spec Editor, then we have this branch table editor, and then we have our catalog editor. So specifically with Spec Editor, it's split into 2 portions, the Spec Sheet Editor, and this is where you're actually going to add in your catalog parts to generate a spec sheet. And then down below here is the actual catalog and where you can actually pull this information from. So what we're going to do is start off with creating a brand new spec. So I'm just going to go to this file and go to new. And I could create a spec. I could create a spec from existing. So if maybe I've already done this beforehand, I could use an existing spec as my basis. But in this case, I'm just going to make one completely from scratch. All right. Now, I get this dialog where I can give this spec a name, and I'm just going to give this a name as KETIV. We'll go with carbon steel 300. And then what I'm going to want to do is define where I want this spec actually saved. And again, this is going to be locally stored normally. So the first spec will be, oh, I should have put 300 too, not 200. The first spec is going to be locally stored. And what you can see is that these specs and these content packs is what they're called, rely on your C drive. So you're going to find these always within your C drive. So if I go to my C drive really quick, I'm going to move this over here. We're going to see a couple different folders, and these are all specifically to the version that you have installed. So I have AutoCAD Plant 3D 2020 in here, and I see various catalogs and content information that I could utilize, all within different standards. So there's AME, ASME, AWWA, DIN, and then common. Okay. So back into Spec Editor, I'm going to go back in, give my spec a name. I could give this a description as well. So I can name this KETIV, carbon steel 300, keeps typing 200, spec. I'm going to let this get populated into my CPAT common. I could redirect it if I need to, but in this case, the CPAT common is totally fine for this right now. And then what you want to do is define and install a catalog to load this up with. So I'm going to look for my ASME pipe fittings catalog. And then now that I have this information here, I could then go ahead and begin to create this. Now that I'm in here, you can see that it generated my spec, my KETIV carbon steel 300, description for it that I gave it, KETIV carbon steel 300 spec. And then it's going to give you some basic information on where this file relies in within your system. I then loaded a spec with it, which is my ASME pipe fittings spec or catalog. I'm going to want to start adding part information to build this spec. Maybe you have your own in-house standard that you're trying to replicate. That way you can leverage it within your Plant 3D environment. You could then pull out that spec sheet and start inputting that information in here. So what I'm going to do is start loading and looking for parts within my catalog. There's a couple different ways you could start filtering. You could utilize this common filters. So if I want to look for fittings, miscellaneous components, fasteners, OLEDs, flanges, or pipe, I could actually boil down to a specific category. And then also a various size range and reducing sizes if I want to. My preferred method is I actually like to use short descriptions over here myself. And what I'm going to do with short description is I'm going to begin to start looking for some components that I want to add within my spec sheet. So what we could do here is let's start off with elbows. I'll add my elbows. And I know for basis, I'm going to start with my schedule standard. So the spec is going to be a schedule standard spec. So I'll go with schedule standard. I filtered my scheduling, and then I found my elbow component with a size range of 1/2 inch to 48 inches. So I'm going to find that, and then I'm just going to simply add that to my spec. That component got populated to my spec. And now I'm just going to go down to the list and start adding additional components in here. So I got my elbow. I know I'm going to need a 45-degree long radius as well. So I'll look for that as well. And it's probably going to be, where are we at? 45-degree long radius. And then I still have it filtered with standard, so that one populated right away. I'll add that to the spec. Now, no, there's a couple different warning signs. I'll get to these after we begin to add the rest of the additional parts for the spec. And I'll show you what these warning signs actually mean. These are part use priority warning signs. And I'll explain these momentarily. So after elbows, we'll go through there and we'll look for, let's look for my flange. I know I'm gonna need a flange socket weld. And I believe that's gonna be a schedule 80. And let's make sure, let's not even give it a schedule. Socket welds don't have schedules. So we're gonna do a pressure class of 300 pound. So here's my pressure class of 300 pound, and I'm gonna look for the exact, I want a raised face. So I just added it and populated it into my spec. Now let's cover the weld neck portion of this, and this one would actually be a schedule 80. Well, let's see if that's in here. Let's change out some of my filtering. And actually, it's supposed to be schedule standard. Oh, I'm in the wrong category. It should be flange. I don't know how that changed. Flange, weld neck. There we go. So here's my flange, weld neck, and then we need this to be pressure class of 300 pound. And then I'm going to find and locate my flange, weld neck 300 pound, and I'm going to add that to my spec. Now let's go down my list and then let's go and find a gasket. So I could find my gasket flat. There's an 1/8 inch thick one right here. 1/8 inch thick, that's a flat face. So let's look for an 1/8 inch raised face, 300 pound. And there it is. After that, we could add, I guess, some T's. Let's cover our full area. So I'll look for T. Let's take off the pressure class rating for this, and then instead let's filter it down to standard. Now I got my butt weld T, so I'll add that to the spec. The next thing I want to capture is a reducing T. So T red, that's going to be your T reducing T. We'll go through that one, and then I could add that as well to the spec. Okay. After this, then we could add some various branch fittings. Let's look for our sockelets. And I'm going to remove this pressure or this schedule. And then we'll look for a sockelet that covers a wide range. So there's a 1/2 inch to 60. I could use that one. And this is going to be a 3000. Different things I'm missing is I'm missing a blind flange. So let's add a flange blind. And then I'm going to set this pressure class at 300 as well. And then there's my raised face. So I'm pretty much just covering every component that I could possibly use within the spec. I think we are missing a bolt set. I don't have my bolt set in there. So let's look for a bolt set. Bolt set right there. And then I'm going to filter that to 300 count, 300 pressure class, and then my facing will be raised face again. And then I'll look for my bolt set, 300 pound, raised face, stud bolt. So that's totally doable. So once you begin to populate all this, you could kind of see that I've already built a spec rather quickly. Now, within this catalog, there's a wide range of sizing. I may not necessarily need all these sizing. Maybe in my particular field, I'm only going up to a 24-inch max size or even a 12-inch max size. So what I'm gonna do, I'm actually missing my pipe. So I need to include my pipe before I start changing my sizing. So I'm gonna look for pipe seamless. And then there should be 2 pipes that I want to add. I should add a schedule 80 for my small bore and then a schedule standard for my larger bore piping. So let's filter this down to standard. Pipe seamless, make sure, and there's no standard. Let's see if there is a schedule 40, it should cover it. So 40 and standard, normally pretty similar. So we'll add this 40 for right now. And then now I'm just going to filter down to my 80 and add my schedule 80 as well. So the first thing I want to do here is begin to change my size ratios. So for my schedule 80 pipe, that's going to be my small bore piping. I'm going to change this. Well, by double clicking onto this line, I could then remove particular sizes off of this spec. I know I'm not going to use any 1/8 inch, any of the smaller bore piping. I'm just going to start from a 3/4 inch up to 1.5 inches. And then I could begin and start clicking the other sizing that I don't need. So I'm gonna, this is a little tedious. This is gonna be the longest part about creating a spec, is all these check marks and check boxes that you have to click and unclick. So depending on your size range, you may have a lot of clicks. So I should be left with a 3/4, 1 inch, and 1.5 inches. That's totally fine. And that's what I see from my size range. Now, once I get into the 2-inch range, I'm going to want to associate 2-inch with my schedule standard, or schedule 40 in this case. So I'm going to remove all the sizing below 2-inch, and then I'm going to remove some unordinary sizes that I probably won't use. So like 5-inch, 3.5, or 2.5. And then for the range, I'll just end this at 12-inch, just for the purpose for this demo. I remove all those sizing. So now I can see in my pipe, I have a range from 2-inch to 12-inch is going to be my schedule 40 pipe, and then my 3/4 inch to 1.5 inches for my piping. Now let's go through and let's match the same size ranges that we did for my piping to our flanges as well. So the socket well flanges are going to be 1/2 inch to 1.5 inches is what I stated. So let's remove the sizing that we don't need. And then my well next will be from 2-inch to 12. So I could remove those odd sizing, and then we could end at 12-inch. There you go. Now, what's important about setting your pipe and the size ranges, what you're going to notice is once we switch to the branch table editor, the header size and the branch size on there is going to be directly correlated to how you define those sizes within the pipe. So whatever size list you have on this list right here is what you're going to see within your branch table editor. So my range is from 2-inch up to 12-inch, and I should see 2-inch, 3-inch, 4-inch, 6, and etc. within my branch table editor for choices that I can make. Now, elbows, let's do the same thing. Let's set our elbow size. So I'm going to double click into my elbows. And because elbows have a wide range of sizing up to 40 inches, and it's going to take a bit for me to remove all these. I'm going to remove all these. And you can see this is a little time consuming.
Well, once you do this the one time, you're good on the whole spec.
Once you do this one time on the spec, you're good. You won't need to redo this. But that's once we get into this a little bit later, why leveraging your own custom catalog, you can remove these unnecessary sizing that you probably will never need for particular components. So we'll talk about that once we get to the,
just based
catalog.
On the components you're putting in your plant, right? You can
Correct.
get rid of a lot of stuff.
Yeah, so we'll leave these. That's okay. I missed 40 somewhere, so let me take that off. So that my size range looks about good now, 1/2 inch to 12-inch, and I'll do the same thing for my 45 degree. Again, I have these large sizing because I'm using one of the standard out of the box catalogs that get installed, and this is just your ASME pack.
It's like Content Center and Inventor. If you're
Exactly.
familiar with that, there's like infinite options, right? And
so now in this case right here, what you see is I have these little exclamation marks right here, these little warning symbols. And what this is telling me is that I need to set a part use priority for when plant chooses to input this information into your piping model. So we have two sizing. We have a 45 degree and a 90 degree. If I double click this or just single click it, I'm going to want to address and tell basically the spec editor what fitting to populate and use as a standard. So more than likely, you're going to want to use 90 degrees first. So what I'm going to do is set my priority to be this 90-degree elbow first. So I'm going to want this on the top, this at number 1. So I'm just going to move this up a level. I'm going to go down my list until I see that these are all at that current upper level. So I wanted to populate my 90 first before it thinks about populating a 45-degree. So we'll add my priority.
Yep, and while Jeff's going through that, what this priority is going to do is when you place it in plant, it'll use the 90 first, correct, Jeff?
Correct.
Default to the 90 as opposed to the 45. And it makes sense because most piping you look at is going to have 90s and not 45s, but sometimes you'll need it, right? So.
Yep. So once I'm done with that, now that I set my priorities and now that I go through my sizing conflict list that I see right here, what I'm going to want to do is mark this all as resolved. So I could do this one at a time and mark it as resolved and apply it out. But in this case, I know that I went through my list. I'm just going to hold shift and make a full selection and mark them all resolved.
And this is different than the other checkboxes, right? The other checkboxes, when you're actually going through each of those components, you have to click them all. You can't do like multi-select.
Yeah. So on the other one, for the actual size ranging, you cannot do a multi-select. So that's where it takes a bit more time. But whereas in part use priority, you can do a multi-select. And I'll show you that in this gasket. If I try multi-selecting, you cannot do anything. So it looks like it's selecting everything, but selecting the checkbox doesn't actually make everything selected. So just be aware of that. So I'm just going to remove some of these really quick.
Yeah, that's the only thing. And if that's something you want them to change, let us know. You can post in the idea station.
I'm sure it's an idea already.
I'm sure it is already.
I'm sure it's an idea already. All right, so we got those. So you can see I'm starting to go through my list, start developing my standard. I'm going to want to make sure that everything is consistent via my size ranges. You can see my bolt set's going up to 24 inches. You know, for right now, I'm going up to 12, so let's make everything consistent. Everyone's going to be able to fully understand what we're trying to implement here first. So everything's starting to be consistent. My OLED size range is going up to 80. What you can see is once we start getting to some fittings, like particularly this reducing T right here, if I go into that size range, there's a various amount of sizing. So this could take you quite a bit of time to start to unselect everything. As you can see, this going up to 48 inch, pretty much trying to cover every possible connection size that you could have for your specific pipe run or branch that you're going to need to connect into. In this case, I'm not going to go through all this right now. This one's going to take quite a bit of time, but I am missing several other components. So I know I'm missing my reducers. I just realized that. So let's go to my reducer concentric and let's add my reducers. And this should be schedule standard. So let's add my concentric reducers. And then let's add the eccentric one as well. So let's go to reducer, eccentric, and let's add that one as well to the spec. And again, in here, you're going to want to give it the part use priority. Now, depending on when you add the actual component to your spec, I added the concentric one first, and then I added the eccentric reducer afterwards. If I reverse the order of these, I would have saved myself a lot of time in this part use priority because it's going to put the last fitting or last item you add to your spec at the top. So you can see my eccentrics number 1, and it's going to be like that all the way down. I would have to then go through here one by one and change out the priority. So in order to save a little bit of time, what I'm going to do really quick is just remove these components and then re-add them to my spec. So right now, let's go back and add this eccentric now. And then I'll go back to my concentric. And now what I should see is in my part use priority now, once I have to define these, is that my concentric should be at the top and then my eccentric at the bottom. So that's a little trick so you can save yourself time. And I'm just going to mark all these as resolved for right now. scroll down to the bottom, mark all as resolved, and then go to apply. Okay. Now, there's a couple other things that I can add to my catalog or to my spec sheet as well, which is going to be a valve. So I'm going to go to open this catalog, and it's going to direct me to my local AutoCAD Plant 3D content. And in here, I'm just going to look for my valves catalog, my ASME valves catalog, and load this into the project as well. I can then filter out and add valves as well into this specification. So if I just go to 300 pound, which we could add a couple of these just so you could kind of see. I'll add some ball valves. I'll add a couple plug valves, maybe a gate valve that I see right here. And these may not align exactly with your specification. I could totally look further into the catalog for something that matches, or again, like the other piping catalogs, you could create your own one from scratch. So we'll just add a check valve as well. So ideally what you want to do is completely set your size range within the spec and then set your part use priority. Once you have that fully dialed down, you're then going to want to go and define the branch table editor. So within this branch table editor, what we're going to see here is the full list of header connections. And again, these are determined by your pipe header or your pipe sizing that you defined. So I have a 3/4 inch up to 12 inch. And then for my branch as well, I have 3/4 inch up to 12 inch. Within here, I'm going to want to begin and define a legend or create a legend. You may have a legend already if you are going to be copying a standard spec that you may have, or maybe even a custom spec. But in this case, I'm just going to create my own legend kind of from scratch right now. So what it takes for you to really create this is, first you have to have those particular components in your spec. That way you could have a selection from. And then you're going to want to go into add branch and then specify the type of branch you want to make. So we'll start off with the OLED first. And then my spec part, actually, I'm going to specify my part. I have that 1/2 inch to 60 inch socket, 3,000 pound, and it's still matching butt weld by socket weld. So we'll use that. I can then define this and give it a legend symbol as well. So we'll name this as SO for right now. And I'm going to do the same for my T. So I'll add my T. I'm going to select my regular T. I'm happy with this legend name that it's giving it, the symbol name T1, because I'm going to have a couple different T variations. I'm going to have a T, a reducing T, and then maybe a T with a reducer as well. So we'll do that one next. We're going to do a T as a possible branch connection. And then I have the ability to add a reducer to it. So I'm going to get added reducer. You'll see that the reducer populates below it, and then I'm going to give it my preferred part, which is going to be my concentric reducer. And that gave it a legend symbol of T2. Now I'll add another T, and this is going to be my reducing T. So we're pretty much telling Plant what particular branch to populate when I'm coming off a pipe run. So now I have my T with my T reducing T, and that's my T3. The last thing I'm going to want to add is a stub-in, so a pipe stub-in. So I'm going to select my pipe, select my pipe size, my 2 inch to 12 inch. And then this one, I could give this another symbol name. We'll go with PE. Once I have this initially set and develop my legend symbol, this should be okay for right now. I could have additional OLEDs in there if I needed to. Maybe you have some weld OLEDs for a specific butt weld spec that you're making, or even a socket weld spec. You could have additional part OLED fittings in there if you need to. And maybe this whole entire symbology needs to be changed to kind of align with your in-house spec. You could totally change what you need to be defined when we populate this branch now. So now I'm just going to click OK. Now in here, we're left with our branch table. Now we have to go through here and actually populate the branches that I want to use. So the first one is a 3/4 inch by 3/4. I can right click and then set one of these to become one of those branches. So I click T3, which is a T reducer. For this particular size, that value is not applicable. So more than likely, this is just going to be a straight T. So I'm just going to set that to T1. 1 inch to 3/4 inch branch, this could be a T2, or actually, let's set this as a socketlet. And then I could add an additional branch. If I go to multi-branch selection here, I could add a PE for my pipe stubbin. And click OK. It's red right there because that pipe stubbin doesn't actually work. So if I tried going back into my multi-branch selection, I could deselect my pipe stubbin and then reselect a new legend symbol that I gave it. So we'll go with this T plus reducer, and that one should work. So pretty much down this line, from 12 inch to, we'll say 2 inch, a pipe stubbin should work for it. So I could select this entire row, right click, and then go to my multi-branch selection, and then select my socklet with my pipe stubbin, and those should work. So I'm not getting any errors at all. I could then, if I know that down this row, 12 inch by 12 inch is more than likely going to be a T. So down this entire row, I could hold Control and make a selection down. And then I can set this to my T. And that's going to be the correct branch to use for it. Same thing with my 1.5 inch. My 1.5 inch more than likely is going to be a T as well. Same thing with a 1 inch, 1 inch by 1 inch. So we can set that as T1. So I'm starting to populate this information in here. And I could go through this list right here. I could go 10 by 12.5. That could be a reducing T, so T3. And T3 does work with that. 8 by 12, we could go through here. Oops. And let me hold Control. And let me do a multiple branch selection. And then let's start with our socklet and our plane end, our PE. So one of these, in one of these particular categories, this isn't going to work. So we'll just click cancel, and we'll see that 8 inch and 6 inch aren't quite working. So 8 inch and 6 inch, we can't do a socklet or a pipe stub end for one of these. So I'm just going to select both of these again, go back into my multiple branch selection, and then reselect these. So I know for those particular sizes, a T plus a reducer concentric and a reducing T should work for those. So I'm going to reassign those. And it did. So you may have a branch sheet already populated, or you may have one already kind of defined. You can kind of get what I'm trying to do here. You're going to want to have this entire branch table fully populated so you could begin to utilize this within your Plant 3D spec environment. I'm just going to go through a couple more here. So from here, we'll just go down through here. From our 1 inch down to 2 inch, this could be a multiple branch selection of a socklet plus maybe even a pipe stubbin. I'm not getting any errors right there. So you're going to want to just quickly add on to these.
Yep, and this is all set up, right? It's similar, like I know a lot of people on here are regular Inventor users. It's the same thing as creating your content center library. It's literally the same concept to be able to utilize some of these standard components for your pipe spec. So there is some, excuse me, some work to do on the front end, but once it's done, right, you do this one time and then you share this with everyone in your organization, and you eliminated all of those options from the catalog that could delay.
Yeah, so yep, so you can see that we're populating this branch table editor. Eventually, you're going to want to have this thing fully populated. And then once this is fully populated, that spec is pretty much good to begin to be used. So in this case, what I'll do really quick is this. I know this spec isn't fully populated, but I'm just going to save it. So I'm going to File, Save. And then I'm going to go into my Plant 3D software now. And then I could actually go and add that spec into my project now. So I have this Spec Editor project that I have right here. And what I'm going to want to do is select my pipe spec folder. Now, right clicking there, I could copy that newly created spec into this project. That way I can begin and utilize that specification into my project. So a dialog box gets loaded, and I'm going to navigate and find that specification that I just created. So it's going to be under my CPAC common. And in this case, I have this KETIV. Where did I save it at? KETIV carbon steel 600. This is one that I have already fully created. So I'll open that. And because it's already exists in this project, so let me just remove it really quick. Let me remove that spec just so you can see this. So I'm going to right click and copy specs of the project, and then I'm going to include my KETIV carbon steel 600. And now within this project, I should see my KETIV carbon steel 600 spec in here. I can then route pipe and assign it to that spec so I can begin to use. So it's a 4-inch pipe. I can route 4-inch piping off of this. I can then branch off of this as well. Change out my various pipe sizing. So we'll change this out to, we'll say a 2-inch. And then you'll see that I'll start to begin to populate my branching based off what I defined to my spec.
Yep. And so everything that it's using here, Jeff, just so I'm following as well, is everything that you added to the pipe spec sheet are the components that it's using here. So it'll never try to use like the 48
Nope.
or anything because we removed those.
Because we removed those from the pipe spec. Now, speaking of those sizing, let me go back into the spec editor really quick. And I kind of want to talk about this catalog editor. Now, with this catalog editor, what you're going to see is this is my standard ASME. For this one, we'll switch it really quick, switch catalogs. This is my standard ASME pipes and fittings catalog. And again, that's going to be under your CPAC ASME common. And this is your standard content. What customers really want to do is be able to leverage this and then input specific information into their own catalogs or build their own unique catalog for their company. So in order for you to do this, I recommend duplicating this catalog essentially. And if you go to new catalog right here, we can give this a name. Or first you want to define the source. So I'm going to find my pipes and fittings catalog, click open. And then I'm going to give this a name. I'm just going to name this KETIV instead of ASME. Pipes and fittings catalog. And then I'll get rid of the copy right here. And then I'll click create. Why I recommend duplicating this is because keeping the standard catalog kind of untouched gives you room and the flexibility to kind of go back and see how catalogs were constructed. So if you're modifying the out-of-the-box catalog and you do changes that you didn't want to do, or it's not functioning properly, you could always go back and refer to the standard catalog and see how it's set up. So now that I have my KETIV pipe and fittings catalog created, what I can then do is begin and implement standard descriptions into some components in here. So what we'll do is I'll just quickly find a flange and I'll show you the editing process of this. So we'll find a flange well neck. And then we'll look for my 300-pound class. And then within my 300-pound class, I found this flange well neck 300-pound raised face. What I'm gonna do is duplicate this component and then give this a new name. I could then define and start changing some of this information. So maybe I want this to say raised face well neck. I'll get rid of that. And I'm gonna get rid of the raised face symbology right here. And then I'll just click OK. I'll click create to create that family. Now I see that it's been created. I'm actually within there, the flange 300-pound raised face wall neck. I'm going to scroll over to my general properties and then begin to edit some of this information to kind of standardize this. So for my manufacturer, I'm just going to give this a name of KETIV. I could then start changing what my long description is. So it's flange, raised face, 300-pound. We could give this a SA 105 for the material, and then the ASME right afterwards, if that's kind of in lines with your in-house standard. You can then define some material code. So maybe I want to give this a material code of SA 105. And that looks about right. So what I'm going to do here is create my, copy my long description that I defined. Now I need to actually input this long description to all the particular sizes. So as we were kind of stating earlier, some catalogs have a wide range of sizing. So in this case, since I'm working with my own catalog, I know that my company is only, limiting sizes up to 12 inches. So I'm going to remove all this sizing that I don't need or I'm never going to use. So I could actually just remove these from my list. So anytime I add these components back into a newly created spec, I'm only going to be limited to these size ranges, and these are going to be less checkboxes that you actually have to deselect or reselect when you're in there. So now I have just a size range of 1.5 inches up to 12. I can remove some of these odd sizing that I probably don't need. And then I'm going to select I'll start from my 1/2 inch, and I'm going to go into this show advanced editing table.
Looks like Content Center
And
to
this
me.
looks very much like Content Center. In here, in this advanced editing table, I'm going to want to edit this long description. So in this case, I'm just going to paste that copy description right below it. And then I'm going to simply just add in the size designation here. And this is going to take place of my newly created long description that I have. I'm just going to cut this out and then paste it over here. So now I've updated my 1/2 inch size. I'm going to want to actually go down my list and then paste this into every particular size. That way it has this updated long description that I gave it. I also have on this right-hand side, I have the ability to edit some of these components in the size parameters. So what you're going to see is like a key legend basically of the component and then the size parameters that you have right here. So when you begin to make these, you're going to want to go through your list, I do just a paste, Control V and paste my sizing, change out my size, and then I'll go down my list. All right. And that's how you're going to end up being able to leverage your custom catalogs and building off of this. Now, once you're done fully editing this, I went down my list, I inputted this size, I can then save this to my catalog once I'm done editing it. And now that I have that saved, I'm going to go back into my general properties and then expand right here. I've built my catalog. I've built my catalog. I've gone through and added various components that are in line with my company standards. I initially defined this. Now I get this all the time is how can you actually share this content to make sure everyone within your environment is on the same plant content itself. So within Spec Editor, you have the ability to modify your shared content folder. So in order for you to do that, you actually need to open this as an administrator. So I'm just going to save this and close out of here really quick. I know we're running low on time, but I'm going to look for my Spec Editor and I'm going to run this as administrator. And you didn't see this populate on my other screen, so I'm just going to move it. But once I run this as administrator, if I go to tools and modify my shared content folder, currently it's pointing to my localized content. I don't want to do that if you have multiple plant admins that are creating specs. What you essentially want to do is copy this data from your local content into a new central server location. So what you can do is by selecting copy all your current standards from your local folder to a new specific shared location. So in my case, I have my external hard drive. I'm just going to click there. And this could represent your shared network location. So it's going to be Autodesk, Plant 3D, 2020 shared content. I'm just going to click OK. And once I have that, I could then just select copy all my content and click OK. Now what you're going to see is on the, let me move this dialog, is it's actually copying all this content to your shared network location. And it's going to allow you and your entire team to be on a collaborative environment, meaning that everyone's not working off localized data, off local libraries that people have built. It's going to be all off a plant admin's environment, ensuring that everyone's utilizing the same information, the same environment, same fittings, same standardizations that you've begun to develop.
Yep, and that's something that we want to kind of relay to everyone. That's something we see underutilized in every program. is that a lot of times employees are in their own silos, right? There may be one or two power users who generate all of their own custom content, but oftentimes that doesn't get shared. Or if it gets shared, maybe some people, if you add someone new, you forget to add that person to that share. So definitely keep that in mind on every application that you use, so that people can all be working off of the same standardized data when it comes to templates, things like the catalogs like this, so on and so forth.
Yeah, so just to kind of bank off that really quick. So now that I started this initial shared content library folder, it will require anyone else within the company to actually map to that folder. So you'd have to go back into open up Spec Editor, tools, and then map and change your shared content folder from your local drive to that shared network drive. That way you're just ensuring everyone's utilizing the same data.
Yep.
That's pretty much it I have for today. I'm planning on going a little bit more advanced with this with our next AVA that we probably do. We'll talk about how you could actually edit this information within Excel. I didn't even show that process yet, but you could actually export these into an Excel document and then edit those within Excel and then bring them back into your Spec Editor. Kind of just ease the process of this manual data entry that you have to do to populate your long descriptions and other various information that you may need.
Yep. Awesome. Thanks, Jeff. I know that this probably was one of the unsexier, I would say, because we didn't really get into the application. We're just in the database the whole time.
Yeah.
But equally as important as using the tool itself is to be able to create an environment in which you work more efficiently, right? If you have the options to, for example, generate every single, iteration of pipe, for example, or some of those reducers or T's, it takes a really long time to find the one you need, especially if your company's not using 3/4, maybe even more than that.
Yeah.
Might as well reduce it at the beginning. You do some legwork at the beginning and you save your work. You save, multiples of that on the back end.
Exactly.
That's something that is really important to us. Hopefully everyone else realizes that, there's a lot of benefit by spending some time when you're starting to use Plant or even Inventor with like Content Center, for example, at the forefront to be able to create your own libraries and get rid of all the unnecessary stuff. Is it possible to change the sizes of parts/equipment? Could be tanks or vessels from quote unquote outside. Could be XML, XLS, or whatever. So Jeff's going to show that possibly next time to be able to change some of the sizing of some of the components you put in there for the pipe specification. When it comes to like equipment,
Plant actually has their own equipment generator, so you could actually generate your own plant. They're kind of bare bones, so you're not going to have a lot of detail that you probably typically see in Inventor, but it's really all you're going to need to actually connect from or route to, specifically within Plant. But there is an equipment builder in Plant. There's a lot of predefined vessels, compressors, lube oil filters, various amount of equipment that you can use within the software itself.
And so Kevin kind of expanded on his question a little bit. So if he builds a model of a tank in Inventor, can you bring it into Plant to plumb it and then bring it back to Inventor to work on the tank more or add it to a complete model of his overall structure?
Kevin, I actually did this on another AVA, bringing in Inventor content into Plant. So I'll make sure to give you a link to that so you could see what we did on there.
So yes, it is possible. Generally, it ends in Plant, right?
It generally ends in Plant. You probably won't want to bring in a tank and then bring it back into Inventor. Specifically, I would probably keep that. If you had the tank modeled inside Inventor, I would model an Inventor, bring it into Plant. I would also use some of the Inventor simplification tools first, bring it into Plant. That way it's a little bit of smaller model. It's not taking up a lot of processing.
Yeah, usually when you build like the piping diagrams and stuff, you don't want full detail because it gets super heavy, super fast, especially if you're modeling, I don't know, an entire facility. And
then you could route all your piping within Plant itself too. So if that's what you want to do, maybe you think piping design is a little bit easier in Plant versus Inventor tube and pipe, you can totally do that.
Yep, and you can route pipe in Inventor.
And you can route piping, yep.
So there's a couple of options to do it. I think it's more efficient most of the time to do it in Plant. So Kevin's asking another question. Does Plant do BOM, bill materials?
Yes. So Kevin, specifically with kind of leveraging, creating your own catalog content is once you actually build your model, you can then run automatic isometrics off of them where it's going to spit out a bill of material within those ISOs. And these ISOs aren't 3D ISOs, they're just 2D line isometrics, but it is going to generate a full bill of material based off the information I laid out within my catalog.
Yep.
So if you're just using the standard catalog, like I said, the information coming out of those is very vague. You probably won't see some information that you're used to seeing currently within your Inventor environment or whatever platform you're coming from. So that's why I recommend kind of creating your own catalog and then start standardizing off of it.
Yep. The more effort you put on the front end, the more you'll get out on the back end. So yeah, like Jeff said, it's super vague. Like Content Center is literally the two are parallels, I think.
Yeah.
If you don't, the descriptions in Content Center and in the pipe specifications are very vague. Things like materials sometimes don't exist, or and then manufacturers and stuff too.
Yep.
So if you create your own for your organization, if you use the same vendors for a lot of this stuff, doing a lot of work on the front end save you a ton of time on the back end. Cool. Let's see. I think that's everything we have for questions, but definitely shoot us emails if you have any more and you think of any in the future. Jeff and I will go ahead and take care of those. But again, Jeff, I'd like to thank you for joining us today to go over some plant stuff.
Thank you, Nigel, for being able to host this and doing this every week for us.
Hey, absolutely. Yeah. And so if you want to know more about plant, let us know. We'll get you some more information. It is something that we think is a little bit underutilized. Maybe because we need to teach people more about it. So maybe we'll have Jeff on here more often.
Yeah.
Cool. Again, thanks everybody for joining us for AVA this week. We'll see you all next week. Thank you and bye-bye.